Hello dear students, let us look at this theorem. Equal chords of a circle or of congruent circles are equidistant from the center or the centers. So we are being told that if there are equal chords in a circle, then they are going to be equidistant from the center. That means their distance from the center, or I should say the perpendicular distance from the center, will be same. So let us first draw a circle for that. So here is our circle, right? And we have a center for this circle over here. This is its center. Let us name it as point O. And now we have two chords which are equal in length. So let us draw two chords. This is chord first. We will name it as AB. And then we have second chord. We have this second chord, we will name it as CD. Right? So these are the two chords which are already given to us to be equal to each other. Now, what else is given? We have to prove that they are equidistant from their center. So for them to be equidistant, let us first draw a perpendicular from the center to both the chords. So it should look like this. Yeah, this is the perpendicular. Let us make it 90 degree to visualize that this is perpendicular. Right, this is perpendicular, that is 90 degrees. And let us drop another perpendicular over here. And this also is 90 degree. Right? Let us join these two sides. Let us join OA and OB. Sorry, OA and OC. Let us make another color for this so that it's visible that we have, yes, and done the construction afterwards. So this is our center O. We have chords AB and CD of the circle to be equal to each other. We have dropped perpendicular OP and OM. Let us write OM. This is the perpendicular OM on AB and this is the perpendicular ON on CD, and we have joined O with A and O with C. Now, what is being given? Let us first write that. So, given AB and CD are equal chords of the circle with center O. What is given? AB and CD are equal chords of this circle with center O. What else is given? OM is perpendicular to AB and ON is perpendicular to CD, right? This is what is given. OM is perpendicular to AB and ON is perpendicular to CD. What have we done? What do we need to prove? Let us write. To prove, we need to prove that OM is equal to ON, because that is the distance from the center of these two chords. So if we prove that OM is equal to ON, then they will be deemed to be equidistant. So we will prove OM equals to ON. let us start the proof. What do we need to do? As I told you, join OA and OC. If I join OA and OC, I see two triangles getting formed. The first one is AMO and the second one is CNO, right? These two triangles, these two right angle triangles are getting formed. If we somehow prove that these two triangles are congruent to each other, we would be able to conclude that OM and ON are equal to each other. So let us move ahead in that direction. Also, if you look at it, since AB and CD are equal to each other, OM is perpendicular to AB, so it bisects AB. So AM is equal to BM now, and since ON bisects CD, CN and DN will be equal to each other. And as AB is equal to CD, half of these two chords will also be equal to each other. That means AM will be equal to CN. We will write it beforehand. So we will write, since AB is equal to CD, so this implies that AM is equals to CN. Why do we know this? Because perpendicular from the center bisects the chord, right? So these two perpendiculars have bisected the chord, and since the chords were already equal to each other, half of them will also be equal to each other. So now in triangle, let us take the triangle AMO and triangle CNO. What do we see over there? The very first thing is angle AMO is equal to angle CNO, both 90 degree. We know that we have drawn two perpendiculars, so these two angles are 90 degree. Now, the next thing that we could take is AO is equal to CO. Why? Radii of the circle. Right? So AO is equal to CO because they are the radii of the same circle. And at last, what we can say that AM, this AM is equal to CN. We just have proved above. So AM is equal to CN. Proved above. So if I now look at these things, this is right angle, this AO and CO are the hypotenuse of those two triangles, and AM and CN are the other sides apart from the hypotenuse of that right triangle. So these two triangles are congruent by RHS congruency. So we can write triangle AMO is congruent to triangle CNO by right angle hypotenuse side congruency criteria. Right? So we just got these two triangles to be congruent to each other using RHS congruency. Now, as they are equal to or congruent to each other, we know that we can use the concept of CPCT. And when we do so, look what are we going to get. So this implies that since these two triangles are congruent to each other, OM is equal to ON, CPCT, corresponding parts of congruent triangles, and since OM is equal to ON, we can say that chords AB and CD are equidistant from the center of the circle. So we can write thus chords AB and CD are equidistant from the center of the circle. So this is how we can prove this theorem. Please note it down for your reference. Thank you so much.